Hi guys, I'm Max, and the project I am working on focuses on developing a thermosensitive liposome formulation of the anti-cancer drug vinorabine and combining it with mild hyperthermia for the treatment of rhabdomyosarcoma. Let's start off with some background information. If we look at all childhood cancer incidences here in Canada, then roughly 6% of those are soft tissue sarcomas, and about half of them fall under the category of rhabdomyosarcoma. That makes RMS a relatively rare cancer that mostly occurs in children. Roughly 1/3 patients experience a recurrence, and most of them occur locally. That means that local control in the treatment of rhabdomyosarcoma is very important. Chemotherapy plays an important role in the treatment of RMS, especially in higher risk patients. Various drugs have been tested. The problem is that successfully treated children often develop long-term treatment-related problems due to a systemic administration of these chemotherapy agents, where only a very small portion of the administered drug actually reaches the tumor. That's why it's important to develop effective localized treatment strategies. This is often done using nanomedicines. Here we have a blood vessel running through the tumor, which is lined with epithelial cells. The nanoparticles are able to accumulate at the tumor through the leaky vasculature and are cleared slower due to an impaired lymphatic drainage, which results in the EPR effect. However, there have been several challenges identified regarding this delivery approach. In order to overcome these, the concept of thermosensitive liposomes was developed. These liposomes release their cargo once being heated. They enter the heated blood vasculature and then rapidly release their cargo. This creates a locally high concentration of drug, which subsequently, along the concentration gradient, penetrates into the tumor tissue. Here, drug distribution no longer depends on the extravasation of the whole nanoparticle, but rather on the physicochemical properties of the drug itself. In this project, we are focusing on loading vinorabine, a drug that has been shown to be active in the treatment of recurrent rhabdomyosarcoma, into such a thermosensitive liposome formulation, and then combining it with hyperthermia to achieve improved local control and reduced toxicity. There are several formulation parameters that need to be taken into account when developing a liposome formulation. We have assessed and optimized several of them to tailor the performance of these thermosensitive liposomes to their specific use. As such, we have now developed a formulation that releases very little vinorabine at body temperature, but rapidly releases when heated above 40 degrees Celsius. So ultimately, the goal is to avoid a widespread distribution of these toxic drugs by non-invasively heating the tumor using focused ultrasound, which then triggers the local release of drug from the thermosensitive liposomes. We hope that this treatment approach will help to improve the care and quality of life of these young patients.